Hey guys, so in this video I'm going to be showing you how to make a photoresistor circuit that is completely operable. Here are the list of materials that you'll need in order to build this circuit. You will need 5 breadboard jumper wires, a USB cable, a 220 ohm resistor, a 10,000 ohm resistor, a Uno R3 controller board, a 830 tie points breadboard, your LED light, your unique photoresistor, and lastly, these two things are optional, but you will need a 9-volt battery with a snap-on clip connector. Remember, these two things are completely optional, but for conventional use, I'm going to be showing you how to do it with both the USB cable as well as the 9-volt battery with the connector clip. So, let's begin construction. Okay, so first we're going to start with our LED. I'm going to go ahead and place it onto the 12 to 15 part of the breadboard on the letter H. Again, just a disclaimer, the placement doesn't really matter on here. Just as long as the whole circuit is completed, then your circuit will work just as fine. So now I'm going to take my 220 ohm resistor and place it on the 15 to the 21st line. 22nd line, sorry. And remember, a key note here is that in order for the circuit to function correctly, they have to be in the same column. Otherwise, your circuit will not work, and then it just won't work. So, next I'm going to connect one of my connector wires. I'm going to place it in the same row as my 12 point for the LED, and I'm just going to go ahead and place it onto the ground of the circuit board. Next thing I'm going to do is I'm going to place another wire onto my resistor. For the key part here is that you need to have it adjacent to wherever your wires are connected. Otherwise, it just will not work because the circuit will not be completed. And I had also put it onto the second digital PMW on the circuit board as well. Remember, you're going to have to take note of that as we will be referencing that in our Arduino program. Next thing I'm going to do is I'm going to take my unique photoresistor that's right here, and I'm going to place it onto the 43 to 46 range onto my Arduino circuit, and I'm just going to go ahead and place this on the very back of the circuit, because if there's because how Arduino circuits work is that once there's an overlap from any part of the circuit within the same row, then it will kind of confuse the photoresistor circuit or any type of circuit, and it just will not work properly as it should. Next thing I'm going to do is, actually this should be right here, right here. And then I'm going to place my resistor right here, starting from where the photoresistor was, and connecting it all the way to channel number 24 on G. Again, make sure that they're both connected properly in the same row. Otherwise, your circuit will not be completed, and yeah. Next thing I'm going to do is I'm going to connect my last wires. I'm going to start with actually the photoresistor. Again, going adjacent to where it starts, the photoresistor, and I'm going to go ahead and connect this wire onto the 5 volts. This is where the power supply is going to be sent whenever I'm going to use this USB cord, and it's just going to start from the photoresistor and then going into a rightwards motion. Next, I'm going to take my next wire, and I'm going to put it adjacent to both the connectors for both the photoresistor and the 10,000 ohm resistor. I'm going to go ahead and place it onto analog A1. This is also very important because in the Arduino program, I'm also going to be referencing that in the setup. Lastly, I'm going to put in my last wire adjacent to this last resistor right here on channel 25 or on channel 54, and then place that onto ground. Once I have this placed onto ground, your circuit should be complete. So it starts all the way right here from the 5 volts, and then it goes all the way onto the resistor, going back to ground, and then picking up back from ground. If the resistor is on, then it'll just use up all the current, and then the LED will not be turned on. However, if the resistor is off, then the current will continue to flow through the resistor and then hit onto this LED, making it light up, and then the resistor, or then the rest of the current goes to the resistor, and then it goes back onto ground. Alright, so the next thing I would be doing is I would plug in this USB cord from the Arduino circuit to my laptop and show you the program, but I'm going to go ahead and link that down into the description below so that you can see the program on how it works and everything. So for right now, I already had put onto the program and downloaded it digitally to the Arduino circuit. Now I'm going to go ahead and take on this 9-volt battery with the clip, and I'm going to go ahead and snap it on. And then I'm going to connect it onto the port right here onto the circuit. It connects right here. Once I do that, you can see the lights turn on and turn on. And right now, of course, the LED is not going to be turned on because there is a light source. So now what should happen is once I turn it off, the LED will get turned on because the resistor is turned off. So let's see how it works. So as you can see, it's fully functional. The photoresistor is operable in showing whenever there is a harsher light, then the LED will not get turned on. However, if the light is dim, then the LED will turn on as so. So I hope you found this whole circuit useful. If you want to incorporate it into other types of machines or devices that use photoresistors, go ahead and give this video a thumbs up and subscribe if you would like, and I'll see you guys in the next video.